See, just now, last class we learned if the current is passing through the coil, it is directly proportional to its deflection. The deflection produced in is directly proportional to current passing through it. The relation between I and theta is directly proportional. So that thing we got it from the moving coil galvanometer. Now, what is the difference between this galvanometer and one more instrument, namely ammeter? See, before entering into the conversion of galvanometer into ammeter, conversion of galvanometer into voltmeter, we have to know the difference of this galvanometer, ammeter and voltmeter. See, galvanometer is a highly sensitive instrument. That is the reason that galvanometer is useful to measuring very small currents. Very small currents in the range, the magnitudes range is 10 to the power of -8 amperes to 10 to the power of -10 amperes. Such as small and low currents we can measure by using galvanometer. For detection purpose, we use galvanometer. But for the measuring purpose and measuring high currents, we use ammeter. For measuring voltages and potential difference, we use voltmeter. So that is the reason everybody must know the difference of all these three. Galvanometer purpose is measuring very small currents and for detection of current, and ammeter purpose is to measure currents and high range currents also we can measure, and voltmeter purpose is to measure the voltages and potential difference. Now in this session we'll see how can we convert this galvanometer into ammeter and how can you convert this galvanometer into voltmeter. So these two concepts we see. See, conversion of galvanometer into ammeter. Conversion of galvanometer into ammeter. How can you convert galvanometer into ammeter? Moving galvanometer into ammeter. So see, first here I am taking galvanometer. For that galvanometer I am connecting a very low value that we call it as a shunt. Now here the entering current is I, the current passing through the galvanometer is Ig, and the current passing through the shunt is I minus Ig according to the Kirchhoff's first law. The sum of the entering current and sum of the leaving currents are same. Both are same. So that is the reason this I and this Ig plus I minus Ig, if you are adding, this Ig cancelled. So finally we get I only. And this circuit you have to connect in series to the external circuit. That means how you have to convert this galvanometer into ammeter. See, if you want to convert a galvanometer into ammeter, first you have to take a very low range of resistance. That very small resistance called shunt. That symbol is given S. That shunt resistance you have to connect parallelly to the galvanometer. then only it is possible to convert this moving coil galvanometer into ammeter. What is happening here? If very low range resistance shunt, if it is connected parallel, whatever the current it is entering here, only the maximum portion of the current can passing through this shunt. Only very little portion of the current can passing through the galvanometer. So that is the reason the galvanometer doesn't drag much current, because the maximum current is passing through the shunt. So usually the problem is if the galvanometer has more resistance, some sort of current it can drive. That is the reason it can alternate the values of current in the main circuit. So in order to avoid that one, very low resistance value, namely shunt, it is connected. So that is the reason the maximum current of more than 90% it is passing to the shunt, and rest of the part only very little 100% only it is passing to the galvanometer. So this is a principle of conversion of galvanometer into ammeter. So once again I am repeating, if you want to convert galvanometer into ammeter, a very low value resistance, namely shunt, which is to be connected parallel to the galvanometer, then you can convert the galvanometer into ammeter. Now this is the main current I. Ig is the current passing to the galvanometer, and I minus Ig is the current which is passing to the shunt. And finally, if you observe the diagram, how this galvanometer and shunt both are in series or parallel? Both are in parallel. If the both are in parallel, what will happen? The potential difference across G and the potential difference across S, both will be constant. So that is the reason here I can write the potential difference across G is equal to the potential difference across S. Both are same. The potential difference is nothing but V is equal to IR. There also V is equal to IR. We can apply Ohm's law. So here I can write the equation like this. Ig into G is equal to I minus Ig into S. And I can write the shunt equation S is equal to Ig into G by I minus Ig into I minus Ig. So finally the shunt we can get S is equal to Ig into G by I minus Ig, shunt value. And similarly, the effective resistance of this combination you can get. How can I get? Here these two resistance G and S both are in parallel. If the both are parallel, how can I get the total resistance? We already know resistance formula in parallel. That formula is R1 R2 by R1 plus R2. Here which one is R1? G. Which one is R2? S. How these two are? These two are in parallel. Parallel means in place of R1 R2 I can use GS. So finally I can get the resistance parallel combination value. It is GS by G plus S. So this is the resistance combination. These two are in parallel. But here one thing you already know. Because this G value is much greater than S. So that is the reason here S can be neglected, and finally resistance in parallel equation becomes GS by G, and G cancel. So finally RP is equal to, you will get S. So finally you see, if the very low value, it is called shunt. If it is connected parallel, then finally the effective resistance is decreasing. Its value will be only S only, because S shunt is very low. So that is the reason the galvanometer, the total ammeter resistance value is very low. So though it is connected in series to the circuit, it doesn't drag much current. So that is the reason the resistance of this ideal ammeter is 0, because here it is shunt. I already told you the shunt value is very low value. So once again, all of you see the explanation part and everything. See, if you want to convert galvanometer into ammeter, first what you have to do? One, a very low resistance value, namely shunt, we have to connect in parallel. I is the main current. The current passing the galvanometer is Ig. The current passing to the shunt is I minus Ig. How we got this I minus Ig? From the Kirchhoff's first law. Yes, here I am writing. You see, I is equal to Ig. This value I don't know. That is the reason I can take some x, and x is equal to I minus Ig, like that. Like that you got I minus Ig. Now here both are in parallel. That is the reason potential across G and potential across S both are same. So I can apply Ohm's law and finally I got shunt equation. And effective resistance, how can I find the effective resistance? Because these two are in parallel. So I can get Gs by G plus S. So if the G value is much greater than S, means that S also cancel, and finally the effective resistance value is equal to S, and finally the resistance of the ideal ammeter is how much it is? 0. Now, how can you convert a galvanometer into voltmeter? How can you convert galvanometer into voltmeter? See, in the previous case, we are connecting a value called shunt parallel. But here, if I am converting a very high resistance, namely R, which is in series to the galvanometer, very high resistance, which is connecting series to the galvanometer, then it is possible to convert galvanometer into voltmeter. Because in conversion of galvanometer into ammeter, we try to decrease the resistance. But here in voltmeter, we try to increase the resistance value. Why? Because ammeter is usually connecting in series in any circuit, but voltmeter is connecting in parallel. So that is the reason ammeter should have low resistance and voltmeter should have high resistance. So that purpose only we are connecting in different ways. So ammeter we are connecting shunt parallel, but in voltmeter we have to connect with high resistance in series to increase the resistance. Now see here, the current passing through the circuit is I, R is the external resistance, and G is the galvanometer. Here I am applying Ohm's law. Here the current passing through the galvanometer is Ig. Now see, V is equal to, applying Ohm's law, Ig into the total resistance value is R plus G. Or V by Ig is equal to R plus G. This G is also taken out. So R is equal to V by Ig minus G. V by Ig minus C. So that gives the value of resistance. Then what is the total resistance in this combination? The effective resistance is equal to, it will be R plus G. Effective resistance is equal to R plus G. Suppose if the R value is much greater than G can be neglected and only R will be there. So that is the reason the effective resistance of the ideal voltmeter is infinite, because it is much greater. So from this one we can convert the galvanometer into voltmeter. Once again, see the explanation part. If you want to convert the galvanometer into voltmeter, first we are taking one galvanometer. For that galvanometer, one high resistance should be connected in series. What happened in the previous case? A very low resistance should be connecting in parallel, but here a very high resistance should be connecting in series. That is the difference. They are parallel, here it is series. Now this is I, the current passing through the galvanometer is Ig. Now here simply I am applying Ohm's law. Potential difference across these points A and B, here I can take, here I can take, potential difference across these points is equal to V is equal to IR. I means current passing. How much it is? Ig. What is the total value of resistance? R plus G. And from this equation I can got R is equal to V by Ig minus G. And finally the effective resistance is equal to R plus G, or G can be neglected, is equal to R. And finally the effective resistance for ideal voltmeter is infinite.